Hey, Will. Uh, Good morning. So now let's start the lesson. So today we will focus on building knowledge for your chapter three. Okay, so we start with the first question. For chapter three, the structure and essay, uh, there are two experiments coming out. So first is this lah. I think you also remember this or not, that we have a magnesium inside. So this magnesium, okay, you will burn it. Okay, you will burn the magnesium with oxygen. Then after that, you'll produce your magnesium oxide. Okay. Then to balance the equation, you have two oxygen here, one oxygen here, put a two here, 2 mg here, 2 mg here. Okay. So they most probably will ask you what is the definition for the what we call either is empirical formula or what is the definition for molecular formula. One of them will come up. So you write down for me what is molecular formula. It's a chemical formula show the actual number of atoms of each element in the compound. Means example, let's say if I give you the glucose, the molecular formula will be the actual number C6H12O6. Okay. Then the empirical formula, they give you the simplest ratio. So 6, 12, 6, right? You simplify to 1 to 1. Okay, you simplify to 1 to 1. Okay, then after that, okay, this is the empty crucible. So the first mass is empty crucible. Second one is you start to add in your magnesium. You add in your magnesium in. Okay. Then the third one, after burn, you actually form oxide. So the oxygen and dot. So in order to get your what we call the magnesium, right? You take number 2 minus number 1. Okay, take number 2 minus number 1. Okay, then because if you take number 2, number 1 is crucible plus lead. Number 2 is crucible plus lead plus magnesium. So if you cancel off, you get your magnesium. Okay, then in order to get the oxygen, you take number 3 minus number 1. So cancel the magnesium, you get your oxygen. This is the basic because today we're going to do the calculation part for the chapter 3. Yeah. Most of the school chapter 3 will be quite a lot of marks in the for the first midterm exam. Okay. Then once you get this today, they will give you the number of mole. Magnesium is 24, oxygen is 16. So you start to divide. So 1.2 divided by 224, you get 0.05. Then 0.8 you divide by 16, you get 0.05 also. You get 0.05 also. Okay, then after that, you need to show me the steps. 0.05 divided by 0.05 equals to 1. 0.05 divided by 0.05 equals to 1. Okay, so the mg and O ratio will be the MgO. This is the empirical formula. This will be the empirical formula. Based on the mass, you're able to calculate out the empirical formula. Later, we have more questions to show you how do you convert empirical formula into molecular formula. Later, you have the equation. So after you get the empirical form is MgO, so I can start to write the equation. Mg burn with O2, then it become MgO. Yeah, Mg burn with O2 become MgO. Then you start to balance the equation. I got 2 O here, I got 1 O here, put 2 here, 2 mg here, 2 mg here. Okay, then after that, to ask you about all these theory question, a very simple one. Why you need to cover with the lid? Okay, when you burn this thing, right? When it from magnesium turn into magnesium oxide, the magnesium oxide, right, might fly out because it's very hot now, and it become powder form. So hot powder, right, the air will bring them to fly out. So once you fly out, your mass won't be accurate. So in order to stop this, we have to close it to avoid the magnesium to fly out. So correct that? To avoid with the white film of magnesium oxide produced escape to the air. This is all this one very popular question in your coming exam. So that most of the school will come out either this experiment or the other copper 2 oxide experiment. Either one of them will come out. So in order for me to avoid the white film of the magnesium oxide, I started with these two basic questions first, because later the calculation I do will be slightly complicated. So need to use this question to build a good base for you first before you enter those calculation question. Okay, then after that, this method is not suitable for copper. So last year you all got learn about the relativity series, right? So like kalau nak kawin mesti ada zinc flexible supaya perempuan hasil cukup. Now, if you look at the reactivity series, right, the one that above, right, we call them more reactive metal. The one that below is less reactive metal. So for copper, right, we can't use this method because if you really take copper and burn with oxygen, the reaction possible to become copper 2 oxide, but the reaction going to be very slow. Okay, so for copper, we don't recommend this method. So you need to write this down. It's less reactive towards oxygen. The reaction is very slow. So it's not recommended to use this method. It's not recommended to use this method. I think it's all the theory. Your coming exam will have one question for the empirical experiment. I want to do this also because just in case it coming out the essay also. Possible to come out essay for the chapter 3, then they will ask about what is the difference between these two experiments. So later we'll go through. So for this experiment, right, only suitable for those metal that more reactive than hydrogen gas. So for this experiment, for this is suitable for metal that is more reactive metal. So this one you need to use the crucible experiment. So the exam time, did you actually the essay will actually ask you this question? So this experiment is suitable for those reactive metal. Okay, then they'll ask you when does the reaction stops? Okay, how do you know the reaction is complete? So the idea is this. Now I try to change magnesium to magnesium oxide. Okay, so of course, magnesium is lighter. Example, I said 5 gram. Then magnesium oxide is slightly heavier. Let's say 9 gram. Okay, 9 gram. So how do I know all the Mg change to MgO? Very simple. Okay, if it changed only 50% Mg, 50% change to MgO, the mass won't be 9 gram. Maybe it'll be halfway. Example, here to here is plus 4, right? So now here we will plus 2. Half of them change. So it becomes 7 gram. Okay, so it means half of the Mg change to MgO. Okay, so but you still have some Mg not change to MgO. So the mass won't become 9, but maybe become half 7 gram. Then if you continue hit, this number might increase to 8 gram. Then continue hit again, you'll reach 9 gram. Once you reach 9 gram, right, 100% has changed the MGO, you realize that if you further hit, right, it will still remain 9 grams because we already all changed the MGO. So this is what we do. How do you know the reaction is complete? You just repeat these three process: heating, cooling, weighing process until your mass you stop at a number, maybe 9 gram. So when the numbers stop at one number and do not increase again, then it means that the reaction stopped already. This is how we know whether the reaction stops or not. Yeah. So this is all the theory that you need to memorize for your coming exam to make sure you can score high marks. So this is the question that what is the pre-question step? Need to cover at interval, but if you fully cover, there's no oxygen inside you. So what we need to do is we need to open it up a while. Then, but if you open up, the white film will fly out, then you fast close it back again. Okay, so this is the theory lah. So this is the first question. We're going to do like two questions for this type of question. Coming out one. So after this question, you have about extra 10 marks in your coming exam. Yeah, so this answer. Anyway, the answer will be available to download later. After today's seminar, then the answer will release out. Then we can start to complete the question. Yeah. So this is the first experiment because you might get one essay that asks you about crucible experiment and the combustion tube experiment. They'll come out maybe comparison or this. So we'll try this question. Then after you okay already, then we'll move on to the normal calculation. Yeah, so then yeah. So now we move on to this the second type of question. Let me choose. Maybe you can take this part. Page. Okay, page 20. Yeah, page 20. Yeah. Okay, so first, this one, you write out the first definition of what is empirical formula. This one give you the simplest ratio of atom of each element of in a compound. Okay, so for this experiment is for metal that below. Kalau nak kawin, mesti ada zinc flexible supaya perempuan hasil cukup anak. So hydrogen is here. So all the metal below, we will use this because exam time the essay might ask you which metal suitable for this method. So this is the one that use those less reactive metal. We're using this. Okay, how this experiment works is very simple. You have zinc here, then you have hydrogen, HCl gas. Okay, so for these two, right, these two chemical will add up together. They actually will produce hydrogen gas. So you can see here, what is the purpose of the zinc granule and hydrochloric acid? You can write like is to produce hydrogen gas because Zn, right, HCl, it will form ZnCl2, then plus hydrogen gas. Balance equation. So you produce hydrogen gas. Huh? So this hydrogen gas, right, it produced. This hydrogen gas will come over the other side. So this is my CuO. So this H2, you come over here, they will actually react with the hot copper 2 oxide to turn back to Cu plus H2O because hydrogen is more reactive. So when more reactive, right, it actually can take away oxygen from the copper. You can see hydrogen is here, copper is here. So hydrogen more reactive than copper, so it can take away the oxygen from the copper 2 oxide. Then after that, form back copper. So in this case, we were able to have the mass of CuO and Cu. So for this, you need to remember the color. So they ask you what is the color change. You went for me, black to brown, because this is black color. The CuO is black color. Then my copper is brown color solid. Brown color solid. The crucible experiment and this experiment coming up one of them will come out. Normally exam lah. But sometimes you see both of them came out in the exam. But normally it will be one of them because their question is very similar. So same now, you will get the mass. So after you get the mass, right, you have the minus. So same, this is the empty one. You have to find out by yourself. Then after that, you have your copper. Then you have your oxide. So in order to minus, this is number one, number two, number three, same method. Number two minus number one to get a copper. Okay, then number three, you just find out the difference. The one with oxygen done without oxygen, then you can get the oxygen mass. So it's a very standard question coming out in your exam. So quite standard one. Then after you get this number already, then you need to take your calculator and divide. They give the mass of copper is 64. Then the mass of oxygen is 16. Yeah. Then you take your calculator, you're able to calculate this 0.2, 0.2. So you get the ratio equals to 1. But you remember to write this. Although you see is 1 now, but you still have to show me 0.2 divided by 0.2. Then here 0.2 divided by 0.2. Now remember one of your essay will be this. One of your structure and possible your essay might be they ask you to compare these two. So remember, one is for more reactive metal, one is for less reactive metal. Okay, once you get your CuO is your empirical formula, then you can write out the chemical equation. CuO burn with hydrogen gas, it actually produce Cu plus H2O. Yeah, so these the questions. Okay, then um why does the hydrogen gas need to flow continuously for a while after the heating is heated? Okay, so for this experiment, a bit dangerous. The reason is because if inside the tube, right, if he has hydrogen gas and oxygen gas, if you heat, right, explosion will occur. So in this case, what we need to do is uh, we will need to continue flow the hydrogen gas in. Because if you keep continue flow hydrogen gas in, you're actually forcing the oxygen to go out. You keep flowing, flowing, flowing. You're actually forcing the oxygen to go out. So you actually remove all the air. So once all the air is removed, inside only got hydrogen, you heat explosion won't occur. Yeah, so this is the idea. Then they'll ask you about and can magnesium oxide use this method? Okay, magnesium oxide, right? If you burn with hydrogen, there will be no reaction. The reason because magnesium is more reactive. Hydrogen is less reactive. So it would able to um, take away the oxygen. So this is those theory that you need to know. Lah. Okay, so I think I do it until here. Because to show you these two experiments, I discussed about these two experiments. First, they will come out in your SR structure. The rest of the answer, you can do it after the seminar. We will give you the answer. Okay, so there will be one possible experiment that asks you to compare these two experiments. Essay question lah. So we move on to the essay question. So you're right there. Okay, so this is the part that I want to cover, which is yep. Can you turn to page 24? Cool. So you might get those, okay, either you want get the question about this, one single question about this, then another potential one is they might get a question that um compare these two. Okay. So now when you compare these two, so you know this is Mg. Okay, this is Mg. And then you know it's burned with oxygen, then produce MgO. Okay, the balancing equation 2O, 2O, 2Mg, 2Mg. Then from on the other side, we know that we preset this chemical is CuO, then burn with hydrogen gas, then the hydrogen take away the oxygen, so it becomes Cu. So you can see one start with metal, it form metal oxide. One started with metal oxide, form back metal. So they will have one question that asks you about these differences. So you need to know the differences between these two. Okay, so we'll skip some questions. Okay, so suggest the metal. You can write down for me. This one is chosen magnesium because it's more reactive. Okay, then second one you choose copper because less reactive. But the more reactive, less reactive, remember to write the one magnesium is more reactive towards oxygen, means it can react easily with oxygen. Then for the second one, copper less reactive than hydrogen gas. That's why the oxygen like taken away by the hydrogen gas. I mean this O2 taken away by the thing. That's why it become the H2O. Do you have this type of question that they want you to compare these two experiments? Because they cannot every year came out the same question. Ask you the crucible, then ask you about the combustion tube experiment. So they might come out something in this for your essay. Structure is possible. Then you ask you the difference between these two. Okay, so remember, one is for the more reactive metal, and the other one is for the less reactive metal. So we move on to this one. Okay, this one also same thing. Um, they want you to compare these two method lah. So I can write down for you. This is Mg plus O2 become MgO and balance equation. Then this is the CuO plus H2. It becomes Cu plus H2. Okay, so now they want you to compare. So for compare, right, you need to tell me the similarity and differences. So what is a similarity? You can see from the diagram, can you see both? It has a words heated. Both has the words heated, right? So you can write the similarity will be both involve heating. Okay. Then the second one, both also involve heating a solid with a gas. Are they accept any logical answer? So because magnesium and copper 2 oxide is a gas, ma. So it's a solid. Then after that, oxygen and hydrogen gas is a gas. So both are a reaction between a gas and a solid. Okay. Then after that, for set one, then they ask for differences. Okay, what is the differences? So first, you can mention about this. The mass increase and mass decrease. The reason is because this one start with Mg ma, then turn into MgO. So with oxygen, your mass should increase. Then another one, this is from CuO, turn to Cu. So from 2% become 1%. CuO is 2%, then Cu is 1%. Then mass decreases. So this is the first differences. Then the second one, okay, right about this. One actually form metal. One actually form metal oxide. Then the last one is react with the oxygen gas. One react with the hydrogen gas. So they will come out quite a simple essay. Looks something like this. They'll ask you to compare what is the difference between these two experiments. So these are all the questions that are coming out in your exam. It won't be exactly the same, but the concept will be the same. They'll ask you to compare these two different experiments. So remember for this experiment, one is for more reactive metal, one is for less reactive metal. Okay, that's it. Then now we will enter into those calculation questions. Calculation questions. Later if we have time, if we can complete the question before the seminar, right? Maybe we can do a bit of chapter two if we have time. Yep. So once your copy finish, we'll try those calculation question. Okay, so these two question, first is very important. Second one, at least do a small revision that you should remember all your empirical formula. Because the question we did later will all related to empirical formula. Okay, so done with it. So now we move on to those calculation question. Everybody turn to page 26. Okay, so we will start with the calculation question. Okay, first thing, for our syllabus, right? You know that number of mole, we have three formula. Okay, so the first formula is mass over molar mass. Second one is volume over molar volume. Third one is number of particle over Avogadro constants. Okay, over Avogadro constants. So the first question, mass is gram, volume is dm cube or cm cube. Third one is the atom molecule ions. So please write down one. These are the important things that you need to know. These are the three formula that you need to know. Okay, you'll get a complicated question from these topics. So we'll do a lot of questions until you're very pro on this type of calculation from chapter 3 lah. Okay, so now for one type of question is they're going to give you a formula. Okay, regardless who is the chemical, they give all of the weird chemical. For this is your Panadol, paracetamol. So based on this paracetamol, they'll ask you to give the chemical formula lah. So very simple one. First, you calculate the number of carbon. Example, here got one carbon, two carbon, three, four, five, six, seven, eight. So you will have eight carbon. Okay. Then the second one you need to calculate is how many H. One, two, three, four, five, six, seven, eight, nine will be H9. Okay. Then after that, how many O you have? One oxygen, two oxygen, O2, and nitrogen we have N1. So this is your final formula. 8C9H O2 and N. Okay, so they'll show you the formula of a chemical. So from there, you need to calculate how many C, how many H, how many N. Uh, the best one is you have to put the C, then H, then O, then N. So 8, 9, 2, 1. This is random. Okay, then after that, what is the relative molecular mass for this chemical? So you can see given here, H is 12, H is 1, carbon 12, then this one 16, this one 14, right? So you can write the relative molecular mass is equals to 8, 9, 2. So carbon is 12, hydrogen 1, oxygen 16, hydrogen 14. So you calculate the number out. So 8 times 12 plus 9 plus 32 plus 14. 151. Okay, then the molar mass, okay, the relative molecular mass, there's no unit. Molar mass, there's unit. So actually, they are the same thing. They are the same thing. Okay, the only difference is relative molecular mass don't have any unit. So, so this is something that I need you to remember. So your coming exam, right? You must remember these are that Both of them are same number, 151, 151. But relative molecular mass is the mass we compare, ma. So there's no unit. The one molar mass, it has unit. So need to be careful for this exam, because if they ask for molar mass, you don't write unit zero. If they write relative molecular mass, you write unit also zero. So both are same number, 151. One has no unit, one has unit, gram per mole. Gram per mole means how many gram? 1 mole. Per mole means 1 mole. Okay, then calculate the mass, the number of the formula of the 500 mg tablet. Okay, you know the Panadol we taken, right? One tablet is 500 mg. So now they want you to calculate out how many molecule inside. So first you must calculate out the 500 mg will equals to 0.5 gram. Okay, then you need to convert the gram into the how many more. Okay, so now we try to convert. I got 0.5 gram divide by 151. This is the example of question that is related to daily life because we take the um, Panadol. So now they want you to calculate how many molecule inside the 500 mg. Okay, so after you get 0.5 divided by 151, you'll get around this number. Okay, get around this number. So now we will need to convert to how many molecule. So you take this number, bring over here. Because number of mole is the same. Number of mole is the same. So you bring over here. But now, instead of finding, you need to find molecule. So I use the general formula first. Number of particle over our constants, then convert to molecule to get how many molecule. We do this type of question. Many questions this is coming exam, you will have many question related to this number of mole mass or molar mass, number of particle over our constants. You have quite a lot of questions from here. A lot of marks. So today we will cover your exam, I think at least 20 to 30 marks. So that you're able to score for this calculation part. Normally the first exam. Two more. You get this? Yeah, so the bring over here times you get this. Okay, so this show you that how do you convert the mass gram into how many molecule. Okay, so gram you use mass over molar mass, then molecule you use molecule over number of particle over the over constants. Okay, okay then here in this question, right, they will mention that um an adult only can take 2 tablets 4 times in 24 hours. So 2 tablet and 4 times means one day maximum you only can take 8 tablet. Okay, 8 tablet. So I will take the number more I times 8 because you only can take 8 tablet. You cannot take more than 8 because if you take more than 8 your kidney is the liver will be failure. Yeah, because actually paracetamol is not is considered a poison to body lah. So you need the liver to detox it. So if you take too much the Panadol, right, then they'll gather at the liver. Then after that will damage your liver. So quite dangerous. So maximum you only can take 8. Okay. Then after that, now they give you mole. They want you to find the mass. So say I got 0.1 mole of paracetamol. So determine the mass. So you can put in the 0.1 mole, 0.15. So 0.15, then mass over 151. Okay, you continue all this calculation until today. You're very good in calculation because I know quite many students for Form 4 for first exam, right? They will be a bit weak on calculation. So you try to solve different type of calculation until you're very pro lah. Chapter 2, if got time we cover today. If don't have, you can try to do it by yourself, or you can go to my YouTube channel to go through also can. I have many videos for chapter 2 for you because the chapter 2 quite okay lah. They only ask like proton number, nucleon number, then isotope, all this. They're all okay, well. Not to say very tough lah. Okay, so you take the 151 times 0.15, you'll get 22.65 gram that is. Yeah, so far this question okay. When I write the formula, how do you know the animation? Oh, so normally we do this. You see, glucose, right? Glucose is the C6H12O6 bar, right? So normally you follow back the sequence C, then H, then O. Normally lah. Then other thing you can write behind. Example, N, whatever other things you can put all behind. Let's say got P, you all put behind. About normally exam they will come out the CHO one normally lah. So any other thing you put behind. We will take 3 to 4 significant. So if you think 4 significant is too much, right? 3 is enough, but at least three. At least three. If you take 2 significant, teacher will give you wrong. At least 3 significant because 3 significant means it ensure that the difference won't more than 1%. They want the difference cannot be more than 1%. If you take 2 significant, the difference can up to 10%. So they don't want. 4 significant is that very accurate if you want. But normally I would take 3 significant because 4 significant sometimes the number is too small. Okay, so today we'll focus on calculation because compare chapter 2 and chapter 3 is like much more harder and a lot of calculation question. If the question looks very complicated, you don't know how to start. For the chapter 2, still okay. Maybe you've got time, maybe we cover a bit later. But I normally don't have time. Now, okay, so you can look at here. This is a questions. Okay, this is a question for similar question. So now, can everybody try to calculate how many C, how many H, how many O? So your teacher cover this type of question. The main reason is because this question, if you careless, you calculate one extra C or one extra O, one extra H, right? Your whole question will get 0. So I let you try. It is in physical class, I saw some student they calculate wrong. It's normal, it's common. So for my recommendation, best you calculate twice. You calculate twice for safety purpose. Because I need this formula for the rest of the question. I also count myself, you count,还不觉得。 Yep, 20 and 20 carbon, 30 hydrogen, and 1 oxygen. Everybody get this? Okay, be careful. This question when you do, right, just careful that don't calculate wrong. If you worry, you can calculate twice. If you calculate twice, you get wrong, it's okay there. I think sometimes this is their destination. So it's then they ask for 1 molar mass. The question is not complicated, but they need you to calculate. They'll give sometimes the school photo stat, right, is not so clear. Then you ask teacher, what is this? What is this? Means you can't see the number, they request. Yeah, because sometimes they when they photo stat, right, the formula not so clear. Yeah, so the molecule molar mass you calculate long. Carbon is this one C20 H30O. So this one will be 20, then this one is 30, then this is carbon is 12, and is 1, string 16. They add up together. Now today we complete all the calculation part, all the tough calculation from the school's past year. All this is school past year. Okay, determine the mass. So similar, you want to find mass, use the mass formula. Then put in your number of mole. So number of mole is 0.025. Okay, so I hope that after today, your calculation become very good because all this calculation, you will bring all this knowledge to chapter 4, 5, 6, 7, 8. So in chapter 8, whether it's good or not will depends on your calculation. So because they always have calculation. Every essay normally 20 marks, right? They will prepare like about 5 marks calculation. If not, essay 20 marks, you do write a lot of theory. So they'll give you 20 marks. Five to 6 marks is calculation. So calculation very important for every exam. Yeah, so you see, from here, I was able to get 7.15 gram. Okay, if you take 0.025, you times the 286. Okay, then the next question, they'll need you to convert the 20.02 gram. They want you to convert into how many molecule. So in this case, um, okay, this is your mass, so use the mass formula. Molecule is under particle formula. So you use back the particle. This is your mass. So now you write number of mole, mass or molar mass. You take the mass divided by your molar mass, which is 286. So you see, if this 286, you calculate wrong, right? Let's say your 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 formula, you calculate, you lesser 1 carbon. So the 286 will become other number. Then after that, then you affect all the results. So remember for this question, calculate the formula twice if possible. Yeah. So now you have your mass. So same, convert your mass into mole first. Mole is the universal unit that is a conversion. Everything you go through mole. So you convert into your mass into mole first. Once you get your mass is equal to your mole equal to 0.007, right? You put this over here. Because everything can convert to mole. After mass can convert to mole, mole can convert to molecule. Mole also can convert to volume. That is. So everything convert to mole first. You get 1 mark here. You get 1 mark for the molecule. You will practice until you're okay with this, huh? You think the exam is coming in. Okay, so for the question below is the balik. They want you to convert the molecule back to mass. So this round is the particle need to convert to mass. So same thing. Take your particle um divide by the Alberta constant first. 6.02 type. So that need to change 6.02. Practice until you're very good in this type of calculation. Yeah. Yeah. So after that, you get the number. Okay. Then bring this number over here. I hope this will help you to get the idea of the number of mole question. You will practice until you feel okay. Practice until you feel okay. Then we can end the seminar. Because you will have this type of calculation, at least one question. So you will today we're going to do two questions. First is the experiment question. No, second one is this type of calculation question. So the exam time you have about 20 to 30 marks from here. Then if you have time later, we can convert, do a bit of chapter two. Okay, so you're okay with the calculation? Yeah, I think some of you a bit weak on the calculation, so we'll practice until you feel okay. So this is you can see a sample question changing the mass into molecule. Then it's a reverse question that changing the molecule back to your mass. So this is how your teacher tests you lah about the calculation part. Okay, so let me check the next question. Yep, we can try again to make sure you are good in this question. So let's try again. You calculate how many C, H, and O for me. So the element that made up the vitamin B will be the CHON B6. Okay, so the key of the question is you need to calculate correctly how many C, how many H, how many O for this. Yeah, so today I tried to complete all the calculation question because calculation question normally will be weak. I calculate, carefully calculate. I also calculate myself, huh? Okay, so you get this? Should be correct, but got 8 carbon, 11 hydrogen, and then oxygen and nitrogen. Yeah. Then calculate the molar mass of the vitamin B6. Okay, so you need to calculate the molar mass. So molar mass equals to 8 carbon, 11 hydrogen, then 1 nitrogen plus 3 oxygen. So put in a number, this is 12. Carbon is 12, hydrogen is 1, nitrogen 14, oxygen 16. Given, right, the mass above? Not given, no. So you need to know this one. Carbon, they'll give you, they'll give this, the mass is given when H is equals to 1, then nitrogen equals to 14, oxygen equals 16. This is given one. Okay, you need to calculate up. Be careful of the calculation because first formula must calculate correct. Then second one is the molar mass also important because I keep repeating using the molar mass. So think carefully. That is 6 plus 11 plus 14 plus 4. I'll get 169. And then remember the unit is gram per mole. So your next month exam, right? Remember, um, if they ask for relative molecular mass, there's no unit. There's no unit for relative molecular mass. But if they ask for molar mass, remember the unit is gram per mole. At some time, I got student forgot to write the gram per mole, then get 0. Also got student that write gram per mole for relative molecular mass, also 0. Okay, so can you try this question? It's a very similar question. Now they got 5.75 gram. They want to convert to how many molecule? Okay, so same. This is the mass formula. This is the particle formula. So let's start the conversion. It's a similar question with the previous one. I practice 3 questions so that you feel confident. So exam question will be very similar. Just the vitamin, this you can see just how vitamin A changed to vitamin B6. Maybe exam time give you vitamin D. It's a similar question. Yeah, so this is first type of calculation. This is a first type of calculation. So you convert, you get mole. Okay, this one I take 4 significant. 3 significant also okay. But I take 4 lah, because you look at the number, you know you take the 3 significant, it looks like 3 significant. Looks like 3 significant. Yeah, so far you all can follow up. So 0.03402, then I don't take 3 significant because if I take it becomes 0.034. So it looks like 2 significant. I take 4 significant in this case. You want to standardize to 4 significant for every question also okay one. Yeah, then you take your calculator, calculate 0.03402 times 6.02 times 10 power 23. See what you get? Yeah, so you'll get this 2.048 times 10 power 32 if you have a calculator. So okay, so your midterm will have all this calculation. Then they want you to find the mass given the mole. They want you to find mass. So this is a simple question. So now this one very simple. You convert your your 0.05 into how many gram? They'll give you a lot of calculation below because if you calculate wrong formula, let's say people is C20 ma, then you calculate C19, right? So technically all the answer below is wrong already. So they'll put a lot of calculation below to make sure that if you calculate wrong number of carbon, so you'll be affected a lot. But if you calculate correct, the overall question is quite simple one. Okay, I see if you're 169 wrong, then a lot of thing gone case with you. 169 is here, 169 is here, 169. So be careful when you try to complete this type of calculation. Okay, the formula is what is the formula there? This number because for empirical formula, right, is the ratio, simplest ratio. But this number is a really simplest ratio because the last number is one now. We can't simplify. So the empirical formula will same with the molecular formula. Now, so if you cannot simplify, just write down the same answer. If you can simplify, then you can write down an example. As I told you, if they give you like C6H12O6, then you can simplify to 1 to 1 ma. But this one no need. This one you can't simplify because you can't simplify one already. One is the smallest number. Okay, so this is the first type of calculation question that you get. Of course, we don't know what is the formula. They can give you paracetamol, can give you vitamin A, vitamin C, vitamin D, vitamin B6. Yeah, so this is the possible question that coming up in your exam, the first type of possible question. Okay, so then we move on to the second type of calculation. Now, second type of calculation actually is a Form 5 calculation that they bring forward to your exam. Same, they will give you a name that you never see before, quinite. Okay, it looks like, wow, teacher, very complicated. What do I say? It doesn't matter because they tell you that this quinite, right, it got this percentage, 74.1% of carbon, 7.4% of hydrogen, and then 8.64% of nitrogen. And the remaining will be oxygen. Okay, so now the first thing you do, you calculate out the oxygen first. So oxygen come from how? How do you get oxygen? It's 100% minus 74.10 minus 7.4 minus 8.64. You get oxygen percentage is 9.86. Then find the number of mole for me. Divided by 60, 12. Be careful. It's also the same thing. The calculation will affect all the result below. So need to make sure you calculate correctly. And the ratio, you should get something quite okay with. Okay, you get a lot of decimal here. You get a lot of decimal. Yeah. Those weird number, it's normal. Because memang in real life, right, you won't get exactly same number. Yeah. So I take four, three significant. Okay, now after you get this video, right, the next step is you need to find out which is the smallest. Smallest, I think, is this. Okay, so all need to divide by the smallest. Get the ratio, so you get around 1 also. Let me check this one. 175 divided by 0.61. You get 10. 10.02 can calculate as 10 a day. Yeah, about 12. So the simple solution will be 10, 12, 1, 1. So the formula will be the C10H12NO. Okay. Now, once you get the empirical formula, they will need you to calculate the molecular formula. So means you get the empirical formula, they want molecular formula. So remember for this type of question, you write out the steps like this. That the empirical formula is like this, molecular formula is bracket N. Another information given here is the actual mass. Because molecular formula is a real formula. And the real mass, this is the real one. Actual formula, we call it actual formula. The empirical formula is the ratio, not real one. So this mass also is an actual mass. So now the next step, I put in the actual formula equal to the actual mass. So the actual formula is C10H12NO bracket N mark. So actual one. Then the actual mass is you put these two together. 324. We put them together. After that, you start to calculate it. Carbon is 10. Hydrogen is 1. So 10 times 12 plus 12 times 1 plus 14 plus 16. You see what is your mass? This one is a very popular calculation. They ask to find empirical formula. Then from there, they ask to find the actual formula. Yeah, so after that, you bring over, you'll get n equals to 2. So after you get n equals to 2, right, you put in the n first. You see this n you get already, so you put it here, 2. Then you get your actual formula will be C20, H24, then N2O2. Okay, once you get the actual formula, they will ask you to convert. For this round, they want you to convert 20 gram into atom. Okay, but if you want to convert gram to atom, first you need to go through molecule first. I had to calculate how many molecules first. Then from how many molecule I convert to atom. I need to show you the difference between convert to molecule and atom, the difference. This is how the previous question, they only convert to molecule, so quite simple. So now you convert to molecule first, but you need the correct actual formula. So the molar mass, you just take 3 to 4 because it will tell you the related molecular mass for the formula is 3 to 4. Okay, for this, you need to convert the molecule first. After get the molecule ready, then you convert to the mass, to the atom. So 20 divided by 3 to 4. You take a calculator and calculate 20 divided by 3 to 4. So hope that today a lot of, I think today we do a lot of calculation question. Then you can see how the exam question looks like. Then you won't get exact same question as I say, they can change the question. Vitamin C, vitamin A, vitamin B, you can see how they change the question. Then nowadays quinine. Later we do a similar question, but they change another chemical. But the concept will be there. The concept will be there. Okay. So you get this idea, then bring over here to get a molecule. So later I will show you the difference that what is the difference between finding molecule and atom. Okay, so you need to convert to molecule first because this is molecule. This is molecule. So you can't convert to atom directly. Because the molar mass you have, the all this is C20H24 N2O2 man. So it's all related to the molecule. So you convert the molecule first. So take a calculator and calculate 0.0167. I take three significant figure. If you want to take four, is okay. Right? No, but normally I take three is enough really. Unless your school teacher varies from that they need four, then you put four for him. Okay. Then after that, you times in, you get a number. Okay, then how about the atom to molecule? Very simple one. So you can see, in here we have how many, in this one, how many atom I have? I got 20 carbon. I got 24 hydrogen. Then I have two nitrogen atom and two oxygen atom. Okay, so the total atom I have will be here. Total, I will have how much? 48 atoms. Okay, so now to convert more, you need to times 48 from atom to molecule, because in C20 we have 20 carbon, and then 24 hydrogen, then two nitrogen and two oxygen. So in this molecule we have 48 atoms. So convert to atoms, you times 48. Yeah, so far okay. So very simple calculation. So it's usually the same. The first question I did is a simple version that convert to molecule. Now this is the second question we did is they actually start to convert to atom. Another one is to convert to ion, is the same concept. Yeah, so this is the calculation question coming out. We won't know how difficult the paper will be, but one of them will be the empirical experiment. One of them will be calculation. At least one of them will be calculation. And then your objective will have a lot of this type of calculation. So now we actually revision or revise the objective. The calculation will be similar to this one. Okay, so far are we okay? So we continue to do. Yeah, you see, a more complicated formula, don't know what is what octane or octyl ethanoate. Okay, so but same information given, carbon, this, and remaining is oxygen. So same concept also. You calculate out the the number of mole first. Okay, so after you get this already, you calculate the mole ratio. We just practice every type of question. We practice three, because first question it might be a bit blur, ma. Second question you start to get try to get the full idea already. Maybe and then the third question you can try to do it by yourself. And to once you're able to do the third question by yourself means you are ready for exam. So every question you practice three. I think we might have time for chapter two later. A quick revision for chapter two. So that today we cover today two question I think has about 30 marks. Then if cover chapter two, then almost 50 marks. But I focus on calculation first because many of you are a bit weak on calculation. So take out a calculator and calculate for me 69.8 divided by 12, 11.6 divided by 1, 11.6 divided by 1, no need calculator, you can get this today. Then after that, 18.6 divided by 16. See how much you get? Take out a calculator, don't copy answer because all this calculation need to go through because you see number from the calculator one, all those weird number. Then how do you from there take three decimal, three significant, four significant, that is. Okay, see you get 5.8166666666. So if you take three significant will be 5.82. If you take four significant will be 5.817. Oh, I take three significant. Yeah. You take four also okay, man. Then after that, from here, we take the smallest. This is the smallest. So all divide by the smallest number. You get the ratio. So check the ratio. 5.82 divided by 6. We get around 5. You then get 10. You then get 1. So the molecular formula will be C5H10O1, like this. Then what else they give you? They give you the actual mass is 172. So same with just now. They tell you the mass is 172. Okay, so you put in that empirical formula equals to C5H10O. Molecular formula will be C5H10O bracket N. Why bracket N? Because you don't know the actual formula. Example, I talk about glucose. Glucose is C6H12O6. So this is the molecular formula. This is the molecular formula. Then the empirical formula is CCH2O. So when I don't know the molecular formula, I put in CH2O bracket N. Bracket N means something that I don't know the actual number. But from here, N equals to 6, because 6 times 1 will get 6, then 6 times 2 is 12, 6 times 1 is 6, then you get back your C6H12O6. So now I put bracket N first because I don't know the actual formula, but I have the actual mass. I have the actual mass. Then from there, I was able to calculate out the real number, the real formula out. Get this? Yeah. Then for that, so okay, the real number, so the real number will be two. Two, you get two already, yeah? Yeah, you roughly know the calculation quite simple. We practice every question we practice three that will be you at least at the end of the lesson you feel that you're confident of this type of calculation. Okay. So after that, similar, they start to ask you to convert it. How many mole you have in here. So now you start to put inside. Wait, although the behind the all the question behind it will be simple. Those simple question this. You have the molar mass is 172, then um they want you to convert 15.48 into mole. So you take 15.48, you divide by the molar mass is 172. So just take this as a very simple calculation, just divide. Lah. Okay, once you divide, you get 0.09. Okay, then we try another type. The question B normally came out in alternative. Okay, I very rarely see it in structural essay one. So this question is this. They give you the mass. Okay, so we write down lah. So the Fe is X gram, then O is 5.04. Then they give you the mass molar mass of the O and um Fe. So now I put in X over 56, 5.04 over 16. So first you calculate 5.04 is equal to how much first? 5.04 divided by 16. I get 0.315. 0.315. Okay, then they give you the ratio is 2 to 1, 2 to 3. Okay, so for this question, right, I need a number for here. How do I get this number? Okay, the ratio is 2 to 3. First, I divide by 3 first to get one part is how much? Because 2 and 3. So I divide by 3 to get one part equals how much? Then I times 2. Because very simple one. If 2 and 3 means that 2 chocolate and 3 chocolate. So 3 chocolate is 31.5 cents. So first I divide by 3 first to get 1 chocolate equals how much? So you see, now I take the 0.0. 0.315 divided by 3. I'll get 0.105. So 0.105 is one chocolate. Then times 2, I'll get this is 0.2. This one normally innovative. Very rare is we can see in structure one. Then after that, you get the this number demand. Then you find your x of 0.56. Then 0.21 times 6. You get 11.79 gram. So now the mass of the Fe is 11.76 gram. That is one type of calculation, but normally objective. Yeah. So once you create data, you move on to the next one. Um, yep, this is another, it's a similar question, but more complicated version. So first, you need to know hydrocarbon. Now, based on hydrocarbon, you should know it inside got hydrogen and then carbon is C. That's why I put in here C and H. Okay. And then he say that got 80.7% is carbon. Then my H will be 100 minus 85.7 equals to 14.3. You need to show the teacher the working. Yeah, you need to show how do you get the 14.3 one. 100 minus 85.7. I need to show to the teacher how they get 14.3. Okay, once you get ready, the next step, you calculate. You remember you need to assume 100 gram, because if you assume you have 100 gram, means 100 gram equals to 100%. Then we can assume 85.7% equals to 85.7 gram. Yeah, that's why you need to show to the teacher that I assuming that I have 100 gram only. It is a similar calculation, but more complicated version. It's a more complicated version. Yeah, so you calculate for me 85.27 divided by 12. 7 divided by 12. You get 7.142. 15.3 divided by 1 no need to calculate. Okay, then with the ratio, you divide by the small number. No? Okay, so you divide. This is the more complicated version that you get the ratio is 1 to 2. This is more complicated version that because sometimes the question every year came out same one, so they need to upgrade the question slightly tougher. Yeah, so you get CH2. Okay, see, based on our previous question, after you get the empirical formula, they will tell you the relative. Normally, this is what they tell her. They tell you relative molecular mass is equals to 172. Example. But this question, they don't give you relative molecular mass. They go one extra step. you have to find out your relative molecular mass. Just now, I'll show you back the question just now. Just now, they will tell you relative molecular mass equals to 172, right? For this one is they got one more extra step. They don't give you the relative molecular mass. You really need to find out. So how do you find out now? They give you another clue to you that 5.6 gram of this compound occupy a volume of this. Okay, from here we will know that 5.6, the mass equals to 5.6 gram, and at the same time the volume is 4.48 dm3. Okay, it means that you see 5.6 gram of this compound means 5.6 gram of this compound occupied a volume of this. So 5.6 gram of this compound is equals to 4.48 dm cube. Okay, so based on these two information, we can find out the molar mass. How do I find the molar mass? It's very simple. Okay, first, I need to convert. So now I write down the formula first. I got number of mole of X equals to mass over molar mass. Then number of mole X equals to volume over molar volume. Okay, what I have 5.6 gram. What I have is 5.6 gram. And then I have 4.48 dm3. Okay, so one side I have the mass, one side I have the volume. Okay, so now what can I do? Because I don't have molar mass, because I don't have the relative molecular mass, means I have to calculate up the number more using the volume first. And we know volume is 22.4 SDP. Okay, good. SDP, so you divide by 22.4. So I calculate first. 4.48 divided by 22.4. I will get 0.2 mole. I get 0.2 mole. Then I bring it over here, 0.2 mole. Yeah, I calculate 0.2 mole. So this one, bring over here, I get 0.2 mole. Then I need to calculate my molar mass now. Molar mass equals to 5.6 divided by 0.2. So my molar mass equals to 5.6 divided by 0.2. I get 28 gram per mole. Then relative molecular mass equals to 28. So this is my final conclusion. Relative molecular mass is equals to 28. Then you can continue your calculation that the empirical formula is CH2, molecular formula is CH2 bracket N, then this CH2 bracket N equals to 28. Then you calculate the mass, the N equals to how much. Yeah, so this is the advanced question that might come out in an exam. So the only difference is they don't directly tell you what is the relative molecular mass. They need you to find out the relative molecular mass by yourself. Yeah, so this is I consider the hardest question you might get. Okay. Then after that, you from here you put in the number lor. Carbon is 12, then hydrogen is 1. Then from there you get n equals to 2. Then you bring over your n equals to 2 inside. Yeah, so you move on to the next one. Okay, so we move on to one more part. Yeah, so I cover a bit on this one. Can you turn to page 36? Page 36, let's just cover a little bit of this topic. Maybe you do a bit of chapter 2 later. A quick one. A quick question on chapter 2. Page 36, huh? Okay, uh this one came out, I think, recently SPM came out. That's why you see a lot of school will ask you this, just in case they repeat again in SPM lah. So we have two type information that you can get from equation. So first is called qualitative, then another is quantitative. So you just remember in the exam, quantitative means quantity. Quantity. How is what is the number? So what you can see, what can you see the number? The number you can see is this one, 8692. Okay. Then this qualitative, you can think about quality. So quality means is this. Okay. Then plus this one. Okay, then now you have two quality uh qualitative information. This is the first one. This is the second one. You have two information. One is you know the chemical is this chemical plus oxygen plus the carbon dioxide and the water. So this is the first qualitative things that you know. The second qualitative things that you know is this one of the bracket. Bracket L means liquid, bracket G means gas, then solid, aqueous this. So first, whether for me, your qualitative information. So in exam, if they give you bracket L, then you talk about the liquid part. If they don't give you, right, or you no need to write solid liquid gas, because what they ask you is the information you can get from this equation. So if your equation inside don't have the liquid, solid, gas, right, then you don't write the answer. So of course, if he has, you need to write, because from the equation you're able to know that you have they are liquid gas. If they don't tell you, you don't write, because you don't know ma. From the equation you don't know is solid, liquid, or gas. But if they're given, you need to write. You need to tell that I can see it is oxygen gas, water, liquid, carbon dioxide gas, all this. This one is very simple and easy marks. Okay, so this is the quality part, the quantitation part. Then after that, the quantity. Okay, the quantity that you know is you see 2, 9, 6, 8. Okay, so the quantity you see 2, 9, 6, 8. You need to write out. So how do you write? This is what you write. 2 stand for 2 mole, 9 4 stand for 9 mole, 6 stand for 6 mole, and 8 stand for 8 moles. But same, you have to relate it to the number. Yeah, so this is the this one is a no need to do second question because it's very similar one. So if this one came out, I think it's a free 3 marks for you. But you need to write all this, only get 1 mark. 2, 9, 6, 8, and then you must link to 2 more is propanol, 9 more is oxygen gas, 6 more is carbon dioxide gas, and 8 more is water. Are you at the MOLE? You're in the MOLE, yeah? Actually, roughly no, but you need to tell the teacher this is qualitative, this is quantitative. This one you get one question like this, a very simple free 3 marks. Okay, now after that, I think if came out structure, right, they'll follow with the calculation. So now they give you, I got this much of propanol I want to burn. Okay, then they'll need you to calculate how many mole of oxygen gas produced and how many mass of water is produced. Okay, so this is the question they ask from you. So now we will refer to this equation. Okay, refer to this equation. So this is the equation. So first you convert your 1.68, you convert to how many moles? So C3H8O. So C is 12. Then hydrogen is, I got 1 and 16. Find out for me, huh? Let's do a simple calculation first. 1.68 divided by 3 times 12 plus 8 plus 16. By looking at the time now, I don't think we have time to go for chapter 2, but chapter 2, you're okay. I will post the answer end of the seminar. Then after that, you can try the question in chapter 2. If after you try the question in chapter 2, you still don't understand, you can WhatsApp me. Here's my number. You can try to WhatsApp me. Any question from the seminar you don't understand, okay? Then after that, the chapter 2, you try to do it by yourself. Lah. I prefer to cover chapter 3 because chapter 3 need the question change. So you need to know how to rack. Like if the question change to another chemical equation, you need to know how to change. Okay, so after that, you get this 0.028. So now what they want is they want oxygen. They want carbon dioxide, right? So I have this. Then I want to find CO2. So if you look at the ratio of mole, can you see this is 2 mole? This is 6 mole. So the ratio is like times 3. So here to here is times 3. Okay. So now what you have, you found that it's 0.028. Okay. So you need to get this, the ratio. So you write this down. From the equation, 2 mole will produce 9. Eh? What do you want to find? Oh, volume of oxygen gas. So they need the oxygen gas, not carbon dioxide. So here, sorry, adjust the place a bit here. So the ratio is 2 to 9. Then you can write log 0.0248. You get this. How do you get this one? Is the same concept just now, that you have to divide by 2 times 9. You'll get 0.126. So the ratio is 2 to 9 mole. So this is 0.028 mole. This one is 0.126 mole. 2 to 9. 2 mole produce a react with 9 mole. Then 0.028 will react with 0.126. How to get 0.126? Very simple. You divide by 2 first to get one ratio, because the ratio is 2 to 9. So 0.028, you divide by 2 first, times 9, you get 0.126, the ratio. Then once you get 0.126, right, you can find the volume. Because you have the 0.126 element, you find the volume. This type of calculation we will bring over to chapter 4, 5, 6, 7, 8. So all your syllabus behind the whole chemistry, all the syllabus will have this type of calculation. Very simple one. So first they'll give you the mass, you convert to mole first. But the only thing is you cannot directly put in here, because the relationship between the propanol and the oxygen is not 1 to 1. So you need to use the relationship 2 to 9 relationship. So you divide by 2 to get one part is how much, then times 9 to get the ratio. Then once you get the ratio 0.126 you can calculate the mass. Yeah, so you calculate the volume. Calculate the volume. Yeah, calculate it. So you get 0.126 times 24. You get the volume equals to this. Okay, I get this idea. Okay, good. Okay, then the next one. They want water. Water this round. They want water. So for water, right, you can see the ratio. For water ratio is here. Um, Same lah. You also take 0.028 divide by 2 times 8. 0.028 divide by 2 times 8. You get the number of mole is 0.112 mole. That's why I put 0.0122 mole. Then same calculation again. You calculate out the mass. So the ratio is just divide by 2 times 8 because the ratio is 2 to 8. So you divide by 2 to get 1 first, then times 8, you get the ratio of this. They're all using the ratio 2 mole, right? 9 mole to form 6 mole and 8 mole. It is. From there, you do the calculation. Then you will get 0.112, then 0.112 plus the mass of water. Water is H2O. So the H is 1, O is 16. Okay, so this type of calculation should be all right for them. If you need more, you can go to my YouTube channel and see. Yeah, I got more example and how to do the calculation. Yeah, so you get the 2.016 gram. So this is the calculation. So okay, so I think you learned this in school already. This is a sample question that you see in your exam. Okay, so maybe we have 2 more minutes. We can do one small chapter two. I just roughly see how the chapter two question looks like. Just a quick one. For chapter two question, right? Most probably you'll get something. Um, Let me find a question that very similar one. You turn to page 13, a quick one. Page 13, this is a simple chapter two question. So for chapter two, right, most probably you will get, you ask definition for isotope. Okay, quite high chance. I think all schools will ask you what is isotope. So this is the answer. You need to write isotope are the atoms of the same element with the same proton number, but with different neutron number. A quick one for chapter two. The question quite standard for chapter two. Only the question for chapter three will be more complicated because they can change the formula. Chapter two, the question similar one. Okay, write this one. Remember, for definition, very strict one. If you're missing one word, will be zero. Of course, if you ask me about this, you can no need to write this one because they give you option that you need to write with the same proton number but different neutron number, or you write the other version that same number of proton but different number of neutron. I'll just stop with this can I? Then they'll give you an example here. From this example, very simple, free 2 marks for you. They'll ask you which two is isotope. By looking at here, you know this is proton number, right? Below is proton number. Above is neutron number. Can you tell me which one is isotope? This is a free 4 marks. 2 marks up. So see here, isotope, they have same proton number, but different neutron number. You just tell me is X and Z. And the reason is just write this off. They have same proton number, but different neutron number. Then you get 2 marks in it. 1 mark here, 1 mark here. And at least you get 4 marks in it. Very, very simple and direct question. Yeah, for chapter two, right? You go to my YouTube channel, you just watch like a three video, each video about 5 minutes at this, then your chapter two covered it. Chapter two covered it. Quite simple one. Because chapter two is a very basic chapter to teach you about the proton number, nucleon number, because we need this information in chapter four, ma. It's a basic chapter. Okay, then after that, so this is the one the 2 marks. So they ask for isotope 1 mark. They ask you to pick which two is isotope. Then you pick X and Y, X and Z. Then after that, then you tell them because they have two same proton number, different nucleon number. Okay. Then one more type of question is this. You need to know how to analyze this. Okay, see, this 6 is proton. This is proton plus neutron. Okay. So you see, Y uh 12 and 6, right? It has 6 proton. 12 minus 6 is 6 neutron. Okay. So now they ask you if another isotope we have 8 neutron. You see, for Y, another Y is 8 neutron. So you see, the proton is same because it's still Y, ma. But the neutron will be different. Original got 6 neutron. Now this time got 8 neutron. So you put a 8 here, neutron here. So now they ask you for the symbol. You can put 14. This is another popular question. They want you to write the symbol of another isotope, which the proton number will be changed a bit. This proton number, this number of neutron is 6. They ask for another neutron, which is 8. So you have to add up together. Okay. Then you ask the uses of the isotope. One of the uses of isotope, right, is carbon 14. So carbon 14 is to determine the age of the fossil, means those things that die already, right? They'll bear under the soil. Then after that, you take it out. Then how do you know this? How long this person have died? You check the carbon 14 to know how long the person died. Then another use of the isotope is sodium 24. So sodium 24 is to track leakage of pipe. Leakage of pipe. This is all the simple question from the for the isotope. You get one question like this, another free 10 marks. You cover one more 10 marks. A quick one. Okay. Okay, then after that, another question is they're gonna ask you to do calculation. Okay, see, for isotope, they have different mass. One is the first one, mass 70, you got 26%. Okay, then after that, 72, and then 73 and 76. Okay, so 72, it has 29.7%. 73 got 7.7%. Oh, got 74. It has this percent. Okay, then 76 has 7.5%. So now they ask you who is the heaviest. They give you this graph and ask you to decide the number. Okay, then after that, how do you calculate the average mass? You just all add up together. Means that 70 times 20.6%, 72 times this 27.4%. Then here is the 7.7% times 73. Then 36.7% times 74, 7.6% times 76 divided by 100%. This is another 2 marks for the calculation, a quick one. Isotope when came out, they'll come out, give you definition of isotope. They give you a few examples, ask you to find out who is the isotope. Then the next one, they'll ask for the uses. So you need to know a common question. Carbon 14, sodium 24, they're coming out this one. Then after that, they'll give you this table. You need to see the percentage, then times in the percent, divided by 100 to get the average mass of the isotope. Also another free 2 marks. This I think is 2 marks. Normally 2 marks, because you to get the number from the date from the graph. And then for the calculation isotope, there's one special question. The special question is this, the last question we did. You see here, they give you two different mass. One is 11, one is the Y. Okay, so we know that 80% of the mass is 11, and then 20% of the mass is Y, and then the average mass is 10.81. So you see, the mass is 10.81, and we have 80% of 11, 20% of Y. Divide by 100, you'll get 10.81. This is another type of question. This one, they give you the question directly, you calculate, divide by 100, you get the actual answer. Now, this one, they give you the final answer, 10.81, and then 80% is 11, the mass, 20%, the mass is Y. That I need you to find out the Y. Okay, so you times, this one bring over here, you get Y equals to 10.05, right? But remember, for the molar mass, we only take the number only. So we don't take 10.05. You need to tell me the final answer is 10. Because the mass is like, means I got boron 11, and then we got boron 10. This is another type of calculation. That instead of giving you 10 here, they give you Y. Then they tell you 80% is 11, 20% is 10. But give you Y, but you take the average, you get 10.81. Then this is what you do. 180 times 11, 20 times Y, divide 100, you get 10.81. 100 bring over here, become 1081. This one bring over here, then divide by 20, you get this. Yeah, so this is the calculation that in the chapter 2. Okay, good. So today will be up to here. So if I'll post the answer to you later after the seminar. Then after that, you can try the rest of the question. If after when you try the question, you don't understand which answer, you can just WhatsApp me. And then if you need revision for other like chapter 1 or that, it is in my YouTube channel. 10.5, which one? 10.5, how to become 11? 10.5, what is the 10.5? Oh, you mean this one? This is 10.05. 10.05, right, is because our mass, you see all the mass here, the nucleon number, we always take whole number one. Always whole number. So 10.005, right? We just assume is 10 already. Because normally we don't do it this one, 10.05 boron it is. Looks very weird. Normally we just straight away round off to 10. Yeah, okay. So you can go to YouTube, find Tian Chemistry to get the my channel and watch all the revision video lah. Okay, so today until here lah. So you can have a lunch first before go for the next class for physics. Okay, bye bye.